Intensive practice 3.1, question number 1. Form system of linear equations for the following situations and answer the questions given. So A, the sum of angle in a triangle is 180 degree. The largest angle is 20 degree more than the sum of the other two angles and is 10 degree more than 3 times the smallest angle. So the question is, what is the measure of each angle of the triangle? So first I'm going to use the letter X, Y, Z to represent the three angles in the triangle, and X will be representing the largest angle, and Z will be used to represent the smallest angle. So therefore Y will become the angle which is in between the largest and the smallest angle. So I just want to name it as the other angle. So next we're going to form the equations based on the questions. So the first one is the sum of angles in the triangle is 180 degree. So which means X plus Y plus Z is equal to 180. The next one is the largest angle, which is the X, is 20 degree more than the sum of the other two angles. So 20 more, so I got to here is going to be 20 plus the sum of the other two angles, Y plus Z. The next one is still referred to the largest angle, which is the X, 10 degree more than 3 times the smallest angle, 10 degree more than 3 times, so I'm going to plus 3Z, the smallest angle, which is the Z. So therefore I have the equations already. So next I'm going to label each of the equations here as 1, 2, and 3. So I'm going to solve these questions by using the substitutions method, and I'm going to use the equations 3 and I'm going to substitute it into the equations 1 and 2. So the X in the equations number 1 will be substituted using 10 plus 3Z plus Y plus Z equal to 180. Next, I'm going to solve for the like term. So Y, so 3Z plus Z here will become 4Z. And I'm going to move this 10 to the other side. So it will be 180 minus 10, which is 170. Next, I'm going to move this 4Z to the other side so that the Y will become the subject of the formula. And I'm going to label this as the equations number 4. Next, I'm going to substitute the equations number 3 into equations number 2. So the X here will be substituted using 10 plus 3Z equal to 20 plus Y plus Z. So I'm going to move this plus Z to the other side. So when 3Z minus Z, I will have 2Z equal to 20. So 20 minus 10, I'm going to move this 10 to the other side. It will be 10 plus Y. And this I'm going to label it as my equations number 5. So next, I'm going to substitute the equations 4 into the equations number 5. So 2Z equal to 10. So the Y here, we're going to substitute it using 170 minus 4Z. So next, I'm going to collect all the Z to my left hand side. So 2Z plus 4Z, I'm going to have 6Z equal to 180. Therefore, Z is equal to 180 divided by 6, which is equal to 30. Therefore, you already have the value of the Z. Next, I'm going to substitute the Z equal to 30 into equations number 3. in order for us to find the value of x. So the equation 3 is x equal to 10 plus 3z. So the z is 30. So therefore it's going to be 10 plus 90 here. So in total I will have 100 for the x. Last one, I'm going to substitute the z, which is equal to 30, into equations number 4 in order for us to find the value of y. So equations number 4, y equal to 170 minus 4z. So here is going to be 170 minus 120. So the y will become 50. So therefore the largest angle is the x is equal to 100 degree. The smallest one, z, is 30 degree. And the angle in between, which is the y, will be equal to 50 degree. B, the sum of three numbers is 19. If the first number is multiplied by 2, the sum of the three numbers is 22. And if the second number is multiplied by 2, the sum becomes 25. Find the value of each number. So first, I'm going to label the first number using the letter X. And the second number, I'm going to label it using Y. And for the third number, I'm going to label it using Z. So first, let us form the equations. So the first of three numbers is 19, which means x plus y plus z equal to 19. Next, if the first number is multiplied by 2, which means the x multiplied by 2 is going to be 2x. The sum of three numbers is 22, which means 2x plus y plus z equal to 22. The third one, if the second number, which is the y, is multiplied by 2, therefore you're going to have 2y, the sum becomes 25. So which means x plus 2y plus z equal to 25. So next I'm going to label each of these equations as 1, 2, and 3. So according to the equations form, it is easier for you to solve this using the elimination method. As for equations 1 and 2, you have equal value for the variable y and z. And for equations 1 and 3, you have equal value of variables x and z. So first, I'm going to use equations number 2. And I'm going to minus the equations number 1. Therefore, I am able to eliminate the y and z straight away. So in this case, it's going to be 2x minus x, which is going to leave you with x alone. So y and z, when you minus it from equations 2 to 1, it will be eliminated. Therefore, straight away, x is equal to 22 minus 19, which is equal to 3. Therefore, you find the value of x straight away when you subtract equation 2 to equations number 1. Next, I'm going to use equations 1 and 3. I'm going to use equations number 3 minus equations number 1. So by doing that, we are going to eliminate the x and z. And what is left is the variable y. So 2y minus y, which we're going to give you y. 25 minus 19, which will give you the number 6. Therefore, straight away, you already have the value of y. Next, we still need to find the variables z. Next, I'm going to substitute x equal to 3 and y equal to 6 into equations number 1 for us to find the z. So therefore, 3 plus 6 plus z equal to 19. So z will become 19 minus 9 here. So 3 plus 6 is 9, and then move it to the other side. So therefore the z is equal to 10. Question number 2, solve the following equations using the eliminations and substitutions method. So questions A here, first of all, I'm going to label each of the equations as 1, 2, 3. So the first method, we're going to solve this using the eliminations method. First, I'm going to use the equations number 1 and equations number 2, because in this case, if you look at here, you have the equal value for the variables x and z. So when I use equations 1 minus equation 2, I will be able to eliminate the x and z. Therefore, straight away, you're going to find the value of y. So you're going to have y equal to 3 minus 2, which is equal to 1. Straight away you have the value of y by using equations 1 minus equations 2. Next, I'm going to use equations 3 and equations 1. As you look at here, you have the equal value for the variable y and z. So when I use equations 3 minus equations 1, then I will be able to eliminate these two variables. So next, equations 3 minus equations 1. So 2x minus x, which is x, will be equal to 5 minus 3, which is 2. So that is the value of x. Next, I'm going to substitute the x, which is equal to 2, into equations number 2 in order to find the value of z. So 2 plus z equal to 2. So z equal to 2 minus 2 when you move these two to the other side, which means z is equal to 0. So next, I'm going to use the substitutions method. So in this case, I'm going to use equations number 2, and I'm going to let the x from the equations number 2. So from 2, I'm going to let the x to become the subject of the formula. Therefore, it will be 2 minus z. This I'm going to label it as equations number 4. So then I'm going to substitute the equations number 4 into 1 and 3. So first, substitute it into equations number 1. The x, we're going to substitute it using 2 minus z plus y plus z equal to 3. Then I'm going to solve for the like terms. So the negative z plus z, this one will be cancelled. So therefore y equal to, then I'm going to move these two to the other side, 3 minus 2, which is equal to 1. Next, I'm going to substitute equations number 4 into equations 3. So it's going to be 2 bracket, the x will be 2 minus z plus y plus z equal to 5. Then I'm going to expand this. So 4 minus 2z plus y plus z equal to 5. Next, solve for the like terms. So y, so negative 2z plus z is going to be minus z equal to 5 minus 4, which is equal to 1. So this will be the equations number 5. So as I already find what is the y is equal to 1, right? So next I'm going to substitute y equal to 1 into the equations number 5. Therefore 1 minus z equal to 1. So I'm just going to move these z's to the other side, and the number 1 to the left hand side. So therefore 1 minus 1 equal to z. Z equal to 0. Last one, I'm going to substitute the z equal to 0 into the equations number 4 to find the value of x. Therefore, x is equal to 2. Equations B. So first, I'm just going to label these as equations 1 to 3. So first, we're going to look at how to solve these questions using the eliminations method. So first, I'm going to look at equations 1 and 2, and I'm going to look at the variables y and z as they have the equal value. Now, in order to eliminate these two, I'm going to use equations number 1 plus the equations number 2. So when 2x plus x, you want to have 3x plus positive y plus with this negative y, it will equal to 0. And then this negative z plus this positive z, it will be 0 as well. So therefore y and z will be eliminated. So next is 7 plus 2, you will have 9. So the x here is equal to 9 divided by 3, which is equal to 3. So next, I'm going to look at equations 2 and 3, and I will eliminate the y here. So next, what happened is that you're going to form an equations with only the variables x and z. And after that, I'm going to substitute the value of x using the number 3, which I find already here. So in order to eliminate the y for equations 2 and 3, I'm going to use equations number 2 plus the equations number 3. So when x plus x, you're going to have 2x. Negative y plus the y, it will be equal to 0. So this positive z plus this negative 3z, you're going to have negative 2z equal to 2 plus 2, which is equal to 4. So I'm going to label this as my equations number 4. Next, I'm going to substitute the x equal to 3 into the equations number 4 to find the value of z. So 2 times 3 minus 2z equal to 4. So I'm going to move this negative 2z to the other side. So it will be 6 minus 4 equal to 2z. So z will be equal to, this one is 2 divided by 2, so z is equal to 1. Okay, next I'm going to substitute the x equal to 3 and z equal to 1 into the equations number 1 to find the value of y. So 2x plus y minus z equal to 7. So y will be equal to 7 minus 6 plus 1. So y will be equal to 2. So this is the first method. And for the second one, which is the substitutions method, I'm going to choose the x from the equations number 2 to become the subject of the formula. So from equations number 2, x is equal to 2 plus y minus z. And I'm going to label this as equations number 4. So next, I'm going to substitute the equations 4 into 1 and 3. So 2x next, I'm going to expand this. Next, I'm going to solve for the like term. So 2y plus y, I'm going to have 3y. And then this negative 2z minus z, negative 3z. Next is the number 7 minus 4, you're going to have 3. So for these equations here, I can simplify it by dividing each term by number 3. So next I'm going to have y minus z equal to 1. Next, I'm going to let the y here to become the subject of the formula. Therefore, y is equal to 1 plus z. And I'm going to label this as my equations number 5. So next, I'm going to substitute the equations number 4 into the equations number 3. So the x will become 2 plus y minus z plus y minus 3z equal to 2. Next, solve for the like term. Plus y, you're going to have 2y. Negative z minus 3z is negative 4z equal to 2 minus 2, which is equal to 0. So here I can simplify it if I want to. I'm going to divide each terms by number 2. Therefore, you're going to have y minus 2z equal to 0. And this will be the equations number 6. So next, I'm going to substitute 5 into 6. So the y will become 1 plus z minus 2z equal to 0. So z minus 2z, you're going to have negative z. So I'm going to move this negative z to the other side. So z will be equal to 1. So next, I'm going to substitute the z equal to 1 into the equations number 5 to find the value of y. So y equal to 1 plus 1, which is equal to 2. Next, I'm going to substitute the y equal to 2 and the z equal to 1 into the equations number 4, as we already let the x to become the subject of the formula. So x is equal to, if you look at equations number 4, it is 2 plus y minus z. 2 plus y minus z. So x will equal to 2 plus 2, 4 minus 1, x is equal to 3. Question C. So first, let us label the equations first. So first, I'm going to solve this using the eliminations method. So first, we need to choose a variable to be eliminated. So in these questions, I'm going to choose to eliminate the x here. So first, as equations 1 and 3, we have the equal value of the x. So first, I'm going to use equations 3, and then I'm going to minus it with the equations 1 to eliminate the x. Therefore, x minus x is equal to 0. So 2y minus y, which is, you're going to get the y, and a positive 3z minus the z, then you're going to have positive 2z. And then 2 minus 3 is equal to negative 1. So this one, I'm going to label it as my equations number 4. So next, I'm going to choose equations 1 and 2. And in order to eliminate the x, the equations number 1, I'm going to multiply it by 2. So therefore, I'm going to have 2x plus 2y plus 2z equal to 6. And this, I'm going to label it as my equations number 5. So now let us focus on equations number 5 and equations number 2. So in order to get rid of the variable x, I'm going to use equations number 5, and then I'm going to minus it with the equations number 2. So 2x minus 2x is 0. This positive 2y minus the y, you're going to get y, and 2z minus negative z. That will give you the answer of 3z. And then 6 minus 6 is equal to 0. And this will be our equations number 6. Now let us focus on the equations 4 and 6. So we have y with the same value, so I'm going to eliminate the y next. So I'm going to use equations number 6 minus equations number 4. So y minus y is 0, 3z minus 2z is z, and then 0 minus negative 1 is equal to the positive 1. Therefore, the z is equal to 1. Next, I'm going to substitute the z equal to 1 into, let's say, equations number 6 to find the value of the y. So y plus 3z, which is 1, equal to 0. So here we have positive 3 when we move to the other side. So you're going to have y equal to negative 3. So here you have the value of y. Lastly, we're going to substitute the y equal to negative 3 and the z equal to 1 into equations number 1 in order to find what is the value of x. So x plus y, so the y is going to be negative 3 plus z, which is 1. It will give you the answer of 3. So therefore x is equal to 3, so negative 3, move the other side, plus 3 minus 1. So x will be equal to 5. So therefore you already solved these questions using the eliminations method. So next we're going to solve this using the substitutions method. So here I'm going to choose, just use the variables x in the equations number 1 as the subject of the formula. So from equations number 1, x will be equal to 3 minus y minus z. So I'm going to label this as my equations number 4. And this is the equations that we're going to substitute into the equations 2 and 3. So first, sub equations 4 into 2. So you're going to have 2 brackets. So the x is 3 minus y minus z plus y minus z equal to 6. Then expand this. You're going to have 6 minus 2y 2z plus y. So next I'm going to solve for the like terms. So first let us look at this negative 2y plus y will give you the answer of negative y. And then this negative 2z minus z is negative 3z. It will be equal to, so this 6 we're going to move to the other side. So 6 minus 6 is equal to 0. Alright, so you have negative y minus 3z equal to 0. So you can simplify this by dividing each term with negative 1 in order to get a positive answer. If you prefer to do that, you can do so. So here you want to have y plus 3z equal to 0. Alright, so as this y here is equal to 1, so I'm going to let the y to become the subject. So y will be equal to negative 3z. Alright, so this will be the equations number 5. So next I'm going to substitute the equations number 4 into equations number 3. So the x will be 3 minus y minus z, and copy the rest from the equations number 3. So next, solve for the like term. Negative y plus 2y will be 1y. And negative z plus 3z is a positive 2z. So move this 3 to the other side. 2 minus 3 is negative 1. Alright, so this will be the equations number 6. So next, I'm going to substitute the equation 5 into the equation 6. So here the y will be negative 3z plus 2z equal to negative 1. So negative 3z plus 2z is a negative z equal to negative 1. Therefore, z is equal to positive 1. Alright, so next I'm going to substitute. I'm going to use the space here. So next I'm going to substitute the z equal to 1 into the equations number 5 in order to find the value of y. So therefore, y will be equal to negative 3. So next, I'm going to substitute the y equal to negative 3 and the z equal to 1 into equations number 4 in order to find the value of x. So here you're going to have 3 plus 3, which is 6 minus 1. So x is equal to 5. So first, let us label the equations. So first method, we're going to look at the eliminations method. So first, we need to find a variables to be, we need to choose a variable to be eliminated. So in this case, I'm going to choose the y. As in equations 1 and 2, I already have the y with the equal value. So first, I'm going to use equations 1 and 2. And in order to get rid of the variable y, I'm going to use equations 1 plus with the equations number 2. So 2x plus 3x will give you the answer of 5x. Negative y plus this positive y equal to 0. This positive z plus with this negative z will be equal to 0 as well. Then next, 6 plus 2 will be equal to 8. So therefore, x is equal to 8 over 5. So straight away, we already get the answer for the x. So next, we're going to continue to eliminate the y by using the equations 2 and 3 in this case. By doing so, I need to multiply the equations 2 by 2 to equalize the value of y. So I'm going to have 6x plus 2y minus 2z equal to 4. This will be my equations number 4. Now let's focus on equations 3 and equations 4. To get rid of this 2y, I'm going to use equations number 4 minus the equations number 3. So 6x minus x is 5x. 2y minus 2y is equal to 0. And this negative 2z minus this negative 4z, it will give you the answer of plus 2z. And then 4 minus 8 is equal to negative 4. So I'm going to label this as my equations number 5. Now, as I already find what is the value of x, so here straight away I'm going to substitute the x equal to 8 over 5 into the equations number 5. So 5 times 8 over 5. So here I can simplify this. So it's going to be 2z equal to negative 4 minus 8. Alright, so z will be equal to negative 12 divided by 2. Therefore, the value of z will be equal to negative 6. So we already find x and z. So now we want to find the value of y. In doing so, I'm going to substitute the value of x and the z. Here I'm going to substitute it into equations number 3, for example. So the equations number 3 is x plus 2y minus 4z equal to 8. So the x is 8 over 5 plus 2y minus 4z equal to 8. So here 2y will equal to 8 minus the 8 over 5. Here we have positive 24. When you move to the other side, it will be negative 24. So solve this, you're going to have y. So here will give you the answer of negative 88 over 5. Then I got to move this number 2 to the other side. So it's going to be multiplied by 1 over 2. So finally, you're going to have y equal to negative 44 over 5. All right, next, I'm going to solve these questions by using the substitutions method. So here I'm going to choose the y from the equations 2 to become the subject of the formula. Because if I substitute into the 1 and 3, I just need to expand it by 1, right? So from equations number 2, the y will be equal to 2 minus 3x plus z. So label it as equations number 4. Then I'm going to substitute this equations number 4 into 1 and 3. So first, sub equations 4 into 1. So you have to have 2x minus the y. So now get this value out of the bracket. You're going to have negative 2 plus 3x minus z plus z. Next, solve for the like terms. 2x plus 3x, 5x. And then this negative z plus z, it will be cancelled. So lastly, we're going to move this negative 2 to the other side. So 6 plus 2 is equal to 8. Therefore, x is equal to 8 over 5. So here we already find the value of x straight away by substituting the equations 4 into the 1. So now next I'm going to substitute the equations 4 into the equations 3. So x plus 2y minus 4z equal to 8. So now expand this. Then solve for the like term. X minus 6x, it will give you negative 5x. And then positive 2z minus this 4z is a negative 2z. Then move this positive 4 to the other side. 8 minus 4 is 4. So I'm going to label this as my equations number 5. All right, as I already find what is the value of x, so next I'm just going to substitute the x equal to 8 over 5 into the equations number 5. So here we can simplify this. So negative 2z will equal to this number 4. Here we have negative 8. When we move to the other side, it's going to be plus 8. So z will be equal to 12 divided by negative 2. So z is equal to negative 6. So next, we still need to find the value of y. So next, I'm going to substitute the value of x and z. Here I'm going to substitute it into the equations number 1. Alright, so you're going to have 2x minus y plus the z equal to 6. So here you're going to have 16 over 5 minus y minus 6 equal to 6. So here I'm just going to move this negative y to the other side and then this 6 to the other side. So it will be 16 over 5 minus 6 equal to y. So here, this one you just solve it by your calculator, then you're going to get y is equal to negative 44 over 5. So first, label the equations 1 to 3. So first, we're going to solve this using the eliminations method. So here, if you look at the equations 1 to 3, the value of y, they are all equal. So therefore, in this case, it will be easier if we choose to eliminate the y. So first, I'm going to use equations 1 and 2. And in order to eliminate the y, I'm going to use equations number 2 minus the equations number 1. So x minus x is equal to 0, y minus y is equal to 0. So when we have 3z minus the 2z, it's just a positive 1z. And 5 minus 4 is equal to 1. So straight away, we already find the value of z. Next, we're going to use equations 2 and 3. In order to get rid of the y, we're going to use equations number 3 minus the equations number 2. So 2x minus x is x, positive 1. And then y minus y is 0. So z minus 3z is equal to negative 2z. And then 2 minus 5 is equal to negative 3. So this one, I'm going to label it as the equations number 4. So next, I'm going to substitute the z equal to 1 into the equations number 4 in order to find what is the value of x. So x minus 2z, so x is equal to negative 3 plus 2. Therefore, the x is equal to negative 1. Alright, so next I'm going to substitute the value of x and the z. In this case, I'm just going to substitute it into the equations number 1. So you have x plus y plus 2z equal to 4. So the x is negative 1 plus y plus 2z equal to 4. So y will equal to 4 plus 1 and then minus 2. So you have 5 minus 2, so y is equal to 3. Alright, so next we're going to solve these questions using the substitutions method. So in this case, I'm going to choose the y from the equations number 1 to become the subject of the formula. Then later on, I'm going to substitute it into the equations 2 and 3. So from 1, so the y will be equal to 4 minus x minus 2z. So this is the equations number 4. Next, substitute the equations 4 into 2. So x plus y, which is the 4, minus x minus 2z plus 3z equal to 5. So here I'm going to get the number out of the bracket. So next, solve for the like sum x minus x, it will be equal to 0. This negative 2z plus 3z is a positive z. Then move this positive 4 to the other side. 5 minus 4 is 1. So straight away we already find the z is equal to 1. So next I'm going to substitute the equations 4 into 3. So 2x plus the y so get it out of the bracket. Solve for the like sum. 2x minus x is x. And then this negative 2z plus z is negative z. Alright, then 2 minus the 4 is equal to negative 2. So this I'm going to label it as my equations number 5. As we already find what is the z, right? So next I'm going to substitute the z equal to 1 into the equations 5. So therefore x is equal to negative 2 plus 1, which is equal to negative 1. Alright, so we still need to find the value of y. So next I just want to substitute the value of x equal to negative 1 and the z equal to 1 into equations number 4. So y equal to 4 minus x minus 2z. So here is going to be 4 plus 1 minus 2. So here you want to have y is equal to 3. So first let us label the equations. So first we want to solve this using the eliminations method. So we need to choose a variable to be eliminated. So in this case, I'm just going to choose the variables x. So first, I'm going to use equations 1 and 2. And I'm going to use equations 1 minus the equations 2. So when x minus x is equal to 0, and then 2y minus negative y, you're going to have 3y. And z minus z is equal to 0, and 4 minus 1 is equal to 3. So therefore y is equal to 3 divided by 3, y is equal to 1. So next I'm going to use equations 2 and 3. And I want to eliminate the x as well. Therefore, for the equations number 2, I'm going to multiply it by 2 to equalize the value of x. So I'm going to have 2x minus 2y plus 2z equal to 2. This will be my equations number 4. Now let us focus to equations 3 and 4. To get rid of the 2x, I'm going to use equations 3 minus equations 4. So 2x minus 2x is equal to 0. This positive y minus the negative 2y will give you the answer of 3y. 2z minus 2z, 0. And then 2 divided by 2 minus 2 is equal to 0 as well. So here you're going to find that the y is equal to 0 divided by 3, which is going to give you the answer of 0. Now, from here we find that the y is equal to 1, and here the y is equal to 0. Now, we know that the 0 is not equal to 1, and the y, they don't have a consistent answer here. Therefore, this system of linear equations, we can say that they have no solutions. Now, if you try these questions using the substitutions method, I'm going to choose the x from the equations 1 to become the subject of the formula. So from 1, so x is equal to 4 minus 2y minus z. So this is the equations number 4. Then I'm going to substitute it into the equations 2 and 3. So the first one is substitute 4 into 2. So the x is 4 minus 2y minus z minus y plus z equal to 1. So solve for the like term. Here we have negative 2y minus y, negative 3y. Negative z plus z, this will be cancelled. And I'm going to move this 4 to the other side. 1 minus 4 is negative 3. So y is equal to negative 3 divided by negative 3, which is positive 1. So next, I'm going to substitute the equations 4 into equations 3. So 2x, the x we're going to substitute it by 4 minus 2y minus z plus y plus 2z equal to 2. Expand this. Solve for the like term. Negative 4y plus y is negative 3y. Negative 2z plus 2z is equal to 0. And then move this add to the other side. 2 minus add is negative 6. So here you're going to find that the y is equal to negative 6 divided by negative 3, which is positive 2. Now, if you look at here, the value of the y, they are not the same, right? So 1 is not equal to 2 for the value of y. As the value of y, they are not consistent. Therefore, this system of linear equations, we can say that they have no solutions. 3. A bakery bakes 3 types of breads, with the monthly cost being 6,850 ringgit for 2,150 loaf of bread. The cost of making a loaf of butterscotch bread is Rm2, a chocolate bread is Rm3, and a coconut bread Rm4. The sale prices of a loaf of butterscotch bread, a chocolate bread, and a coconut bread are Rm3, Rm4.5 and Rm5.5 respectively. If the bakery make a profit of Rm2,975 monthly, how many loaves of each type of bread will it bake? So first, let us label the number of loaf of butterscotch bread as X, and the chocolate Y, and then the coconut as the Z. So first, let us form the equations based on the questions given. So first, we have the information of this one. So 3 types of breads, they are doing 2,150 loaves of bread monthly. So the first one is going to be the X plus the Y plus the Z for these 3 bread. They will have the total number of 2,150. Okay, the second equations we can form based on the cost. So a butterscotch bread is Rm2, the chocolate bread is 3, and the coconut bread is 4. And the monthly cost is 6,850. So to calculate the cost is going to be 2x plus 3y plus 4z equal to 6,850. So the other information that we can find is the profit, which is 2,975. So we have given the selling price of each of the bread. So the butterscotch is 3, chocolate is 4.5, and the coconut bread is 5.5. So in order for you to get the profit, all right, so in order for you to get the profit, is going to be the selling price minus the cost. Therefore, we can set that the profits for the butterscotch is going to be 3 minus the Rm2. So therefore, the profits for the butterscotch is going to be X. And then the profit for the chocolate bread is 4.5 minus 3, which is 1.5. Then we're going to multiply it with the number of loaf, which is the Y. And then plus with 5.5 minus the 4, which is 1.5 as well. And don't forget to multiply with the number of loaf of the coconut, which is the Z. Then this is going to give you the profits of 2,975. All right, so next I'm going to label these three equations. Now you can solve this using eliminations method or the substitutions method. So in this case, I just want to solve this using the eliminations method. So I'm going to choose to eliminate the X here. As for equations 1 and 3, I already have the equal number for the X. So first I'm going to use equations number 3 minus the equations number 1 to get rid of the X. So X minus X is equal to 0. Then 1.5y minus the 1y, you're going to get 0.5y. And then the same as the 1.5z minus the z, you also get 0.5z. And then 2,975 minus the 2,150, you're going to have 825. So this will be the equations number 4. So next I'm going to use equations 1 and 2. And then I'm still going to eliminate the X. So for the equations number 1, I'm going to multiply it by 2 in order to equalize the value of X. So you're going to have 2x plus 2y plus 2z equal to 4,300. And then this will be your equations number 5. So now let us focus on equations 5 and equations number 2. To get rid of the 2x, I'm going to use equations 2 minus the equations 5. So 2x minus 2x is 0. 3y minus the 2y here, I'm going to have 1y. And then the 4z minus this 2z, I'm going to have 2z. And then the number 6850 minus the 4300, you're going to have 2,550. All right, so this will be the equations number 6. So now let us focus on equations 4 and equation 6. So next, if you want to continue using the eliminations method, so next I'm going to choose to eliminate the y. So first I need to equalize the y first. So for the equations number 4, I'm going to multiply it by 2. So when 0.5y multiplied by 2, you're going to have 1y. And then 0.5z multiplied by 2 is 1z. And then to add to 5 will become 1650. So this will be the equations number 7. Now I already have the y of the same value. I'm going to use equation 6 minus the equation 7. So y minus y 0, 2z minus z is z. So the number 2550 minus 1650 is equal to 900. Therefore, we already find the coconut one. The number of loaf for the coconut is 900. So next, I'm going to substitute the z, which is equal to 900. Here, I'm going to substitute it into equation 7, for example. So y plus 900 will be equal to 1650. So y will be 1650 minus 900, which is 750. So next, I'm going to substitute the y, which is 750, and the z, 900, into equations number 1. So to find the value of x, so x plus 750 plus 900 equal to 2150. All right. So later on, you're going to move this 750 and 900 to the other side. So therefore, x is going to be 500. Questions number 4. Andrea sells flower pots of different sizes. The price of a small flower pot is Rm10, medium flower pots Rm15, and the large flower pots Rm40. So every month, the number of small flower pots sold is equal to total number of the medium and large flower pots sold. The number of medium flower pots sold is twice the number of the large flower pots sold. Andrea needs to pay a rent of Rm300 per month for her business premise. So what are the minimum numbers of pots of each size which Andrea has to sell in a month so that she can pay the monthly rent? So first, we're going to label the small flower pots as X, the medium one as Y, and the large one as the Z. So next, we want to form the equations based on the questions given. So the first one is the number of the small flower pots sold, in this case, which is the X, is equal to the total number of the medium and the large flower pots sold. So here is going to be Y plus Z. Next, the number of medium flower pots sold. So here the medium is the Y, is twice the number of the large flower pots sold. So the large one is Z, twice is going to be 2Z. So the next one, equations, you can form it from the monthly selling price so that she can pay the monthly rent, which is the 300. So we know that the small flower pot is Rm10, the medium one is 15, and the large one is Rm40. So therefore, 10 times X plus 15 times Y plus 40 times Z, it must be equal or more than 300, right? So here the minimum, so we're just going to use 300. So next, I'm going to label this as equations 1, 2, and 3. So here I'm just going to use the substitutions method, as I already, for example, in equations 1 and 2, I already have X or the Y as the subject of formula. So here I'm going to use equations number 2, and I'm going to substitute it into the equations number 1 and the equations number 3. So first I'm going to substitute the equations number 2 into equations number 1. So x is equal to y, which is 2z plus z. So x is equal to 3z. So I'm going to label this as equations number 4. Next, I'm going to substitute the equations number 2 into equations number 3. So the y here, we're going to use 2z plus 40z equal to 300. So here you're going to have 10x plus 30z so 10x plus 70z equal to 300. So this will be the equations number 5. So next I'm going to substitute the equations 4 into the equations 5. So 10x, so I'm going to substitute it with 3z So here you have to have 30z plus this 70z, so 100z equal to 300. So z equal to 300 divided by 100, so z is equal to 3. So next I'm going to substitute the z equal to 3 into equations 4 to find the value of x. So x is equal to 3 times 3. So the x is equal to 9. So next I'm going to substitute the z equal to 3 into equations number 2 in order to find the y. So y is equal to 6. Question number 5. Mr. Chong intends to purchase a few chickens, rabbits and ducks for his farm. The total number of animals is 50. He has 1,500 ringgits to be spent. A chicken costs Rm20, a rabbit Rm50 and a duck Rm30. The number of chickens is equal to the number of ducks. How many of each animal should Mr. Chong purchase? Write a system of linear equations to solve these problems. So first we're going to label the chicken as x, the rabbit as y, and the duck as the z. So now we're going to form the equations. The first one is from this sentence. The total number of animal is 50. So we know that x plus y plus z equal to 50. The second equations, Mr. Chong has Rm 1,500 ringgit to spend, and we know that the cost for each animal. So the next equations will be the cost for the chicken is going to be 20x, and the rabbit is going to be 50y, and the duck is going to be 30z. And this will be equal to 1,500 ringgit that Mr. Chong has. So the third equations, the number of chicken is equal to the number of ducks. Chicken is equal to the number of ducks, so x is equal to z. Alright, so next we're going to label this as equations 1, 2, 3. So here I'm going to solve these questions using the substitutions method. As from equations number 3, we have x as the subject of the formula. So I'm going to substitute 3 into 1 and 2. So the first one, substitute equations 3 into 1. So the x, we're going to replace it with z. Solve for the like term, y plus 2z equal to 50. Then I'm going to let this y to become the subject of formula. So this will be my equations number 4. So next, I'm going to substitute the equations number 3 into equations number 2. So 20x will now become 20z. So here we're going to have 50y plus 50z equal to 1500. So here, if you want to simplify it, also can. So I'm going to divide each of the term here by 50. So here I'm going to have y plus z equal to 30. Alright, so this will be my equations number 5. So next, I'm going to substitute the equations 4 into 5. So the y in equations 5, we're going to replace it with 50 minus 2z plus z equal to 30. So negative 2z plus z is negative z. 30 minus 50 is negative 20. Therefore, z is equal to 20. So as we know that the x is equal to z, right? So the x will be equal to 20 as well. And now we need to find the value of y. So next I'm going to substitute z equal to 20 into equations number 4. So y equal to 50 minus 2 times 20. So y is equal to 50 minus 40. Then y will be equal to 10.